Like algebra, the branch of mathematics called geometry is a mathematical system. Each system has its own vocabulary and properties. In the formal study of a mathematical system, we begin with undefined terms. Building on this foundation, we can then define additional terms. Once the terminology is sufficiently developed, certain properties, characteristics, of the system become apparent. These properties are known as axioms or postulates of the system. More generally, such statements are called assumptions. Once we have developed a vocabulary and accepted certain postulates, many principles follow logically when we apply deductive methods. These statements can be proved and are called theorems. The following box summarizes the components of a mathematical system, sometimes called a logical system or a deductive system. 4 parts of a mathematical system. Number 1, undefined terms. Number 2, defined terms. Vocabulary. Number 3, axioms or postulates. Number 4, theorems. Principles. Terms such as point, line, and plane are classified as undefined because they do not fit into any set or category that has been previously determined. Terms that are defined, however, should be described precisely. But what is a good definition? A good definition is like a mathematical equation written using words. A good definition must possess 4 characteristics. Definition. An isosceles triangle is a triangle that has 2 congruent sides. In the definition, notice that number 1, the term being defined, isosceles triangle, is named. Number 2, the term being defined is placed into a larger category, a type of triangle. Number 3, the distinguishing quality that 2 sides of the triangle are congruent is included. Number 4, the reversibility of the definition is illustrated by these statements. If a triangle is isosceles, then it has 2 congruent sides. If a triangle has 2 congruent sides, then it is an isosceles triangle. In summary, a good definition will possess these qualities. Number 1, it names the term being defined. Number 2, it places the term into a set or category. Number 3, it distinguishes the defined term from other terms without providing unnecessary facts. Number 4, it is reversible. Definition. A line segment is the part of a line that consists of 2 points, known as endpoints, and all points between them. Considering this definition, we will see that number 1, the term being defined, line segment, is clearly present in the definition. Number 2, a line segment is defined as part of a line, a category. Number 3, the definition distinguishes the line segment as a specific part of a line. Number 4, the definition is reversible. A line segment is the part of a line between and including 2 points. The part of a line between and including 2 points is a line segment. Recall that a postulate is a statement that is assumed to be true. Postulate 1. Through 2 distinct points, there is exactly 1 line. Postulate 1 is sometimes stated in the form 2 points determine a line. See Figure 1.31, in which points C and D determine exactly 1 line, namely line CD. Of course, Postulate 1 also implies that there is a unique line segment determined by 2 distinct points used as endpoints. In Figure 1.32, points A and B determine line segment AB. In Figure 1.33, how many distinct lines can be drawn through A, point A, B, both points A and B at the same time, C, all points A, B, and C at the same time. Solution. A, an infinite or countless number. B, exactly 1. C, no line contains all 3 points. The symbol for line segment AB, named by its endpoints, is AB with a straight line over the top. Omission of the bar from line segment AB, as in AB, means that we are considering the length of the segment. These symbols are summarized in Table 1.3. A ruler is used to measure the length of any line segment, like line segment AB. This length may be represented by AB or BA. The order of A and B is not important. However, length AB must be a positive number. Postulate 2. Ruler postulate. The measure of any line segment is a unique positive number. We wish to call attention to the term unique and to the general notion of uniqueness. The ruler postulate implies the following. Number 1. There exists a number measure for each line segment. Number 2. Only one measure is permissible. Characteristics 1 and 2 are both necessary for uniqueness. Other phrases that may replace the term unique include one and only one, exactly one and no more than one. A more accurate claim that the commonly heard statement, the shortest distance between 2 points is a straight line, is found in the following definition. Definition: the distance between 2 points A and B is the length of the line segment AB that joins the 2 points. Postulate 3. Segment addition postulate. If X is a point of line segment AB and AXB, then the length AX plus the length XB equals the length of AB. Definition: congruent symbol, line segments are 2 line segments that have the same length. In general, geometric figures that can be made to coincide, fit perfectly one on top of the other, are said to be congruent. The symbol congruent is a combination of the symbol similar, which means that the figures have the same shape, and equal, which means that the corresponding parts of the figures have the same measure. In Figure 1.35, line segment AB is congruent to line segment CD, and line segment AB is not congruent to line segment EF, meaning that line segment AB and line segment EF are not congruent. Does it appear that line segment CD is congruent to line segment EF? Definition: the midpoint of a line segment is the point that separates the line segment into 2 congruent parts. In Figure 1.36, if A, M, and B are collinear, and line segment AM is congruent to line segment MB, then M is the midpoint of line segment AB. Equivalently, M is the midpoint of line segment AB if length AM equals length of MB. Also, if line segment AM is congruent to line segment MB, then line segment CD is described as a bisector of line segment AB. If M is the midpoint of line segment AB in Figure 1.36, we can draw these conclusions. Length AM equals length MB. Length MB equals 1/2 length AB. Length AB equals 2 times length MB. Length AM equals 1/2 length AB. Length AB equals 2 times length AM. Definition: ray AB, denoted by AB with an arrow over the top, is the union of line segment AB and all points X on line AB such that B is between A and X. In Figure 1.37, line AB, ray AB, and ray BA are shown. Note that ray AB and ray BA are not the same ray. Opposite rays are 2 rays with a common endpoint. Also, the union of opposite rays is a straight line. In Figure 1.39a, ray BA and ray BC are opposite rays. The intersection of 2 geometric figures is the set of points that the 2 figures have in common. In everyday life, the intersection of Bradley Avenue and Neal Street is the part of the roadway that the 2 roads have in common. Figure 1.38. Postulate 4. If 2 lines intersect, they intersect at a point. When 2 lines share 2 or more points, the lines coincide. In this situation, we say there is only one line. In Figure 1.39a, line AB and line BC are the same as line AC. In figure 1.39b, lines L and M intersect at point P. Definition: parallel lines are lines that lie in the same plane but do not intersect. Another undefined term in geometry is plane. A plane is two-dimensional. That is, it has an infinite length and infinite width, but no thickness. Except for its limited size, a flat surface, such as the top of a table, could be used as an example of a plane. An uppercase letter can be used to name a plane. Because a plane, like a line, is infinite, we can only show a portion of the plane or planes, as in figure 1.41. A plane is two-dimensional, consists of an infinite number of points, and contains an infinite number of lines. Two distinct points may determine or fix a line. Likewise, exactly three non-collinear points determine a plane. Just as collinear points lie on the same line, coplanar points lie in the same plane. In figure 1.42, points B, C, D, and E are coplanar, whereas A, B, C, and D are non-coplanar. Points shown in figures are assumed to be coplanar unless otherwise stated. For instance, points A, B, C, D, and E are coplanar in figure 1.43a, as are points F, G, H, J, and K in figure 1.43b. Postulate 5. Through three non-collinear points, there is exactly one plane. On the basis of postulate 5, we can see why a three-legged table sits evenly, but a four-legged table would wobble if the legs were of unequal length. Space is the set of all possible points. It is three-dimensional, having qualities of length, width, and depth. When two planes intersect in space, their intersection is a line. An open greeting card suggests this relationship, as does figure 1.44a. This notion gives rise to our next postulate. Postulate 6. If two distinct planes intersect, then their intersection is a line. The intersection of two planes is infinite because it is a line. See figure 1.44a. If two planes do not intersect, then they are parallel. The parallel vertical planes R and S in figure 1.44b may remind you of the opposite walls of your classroom. The parallel horizontal planes M and N in figure 1.44c suggests the relationship between ceiling and floor. Imagine a plane and 2 points of that plane, say points A and B. Now think of the line containing the 2 points and the relationship of line AB to the plane. Perhaps your conclusion can be summed up as follows. Postulate 7. Given 2 distinct points in a plane, the line containing these points also lies in the plane. Theorem 1.3.1. The midpoint of a line segment is unique. If M is the midpoint of line segment AB in figure 1.45, then no other point can separate line segment AB into 2 congruent parts. M is the point that is located 1/2 AB length units from A and from B.